So, in the previous class, we learned what are called matrix addition and scalar multiplication. Now, we would like to look at what is called matrix multiplication, which is very important thing and the crux of matrix theory. So, as I said, it is the crux, so it means that it has to play an important role and we need to give sufficient time to understand matrix multiplication. So, let me try that out. Let us try to understand matrix multiplication. So, we have learned this matrix multiplication in our school, but would like to proceed further and understand it in a better way. So, given a matrix A m cross n and a matrix B which is say P cross Q of different sizes, A has entry Aij, B has entry Bij, then we can talk of A times B matrix multiplication or matrix product, whatever you want to say, if n is same as P. So, n means number of columns of A should be equal to number of rows of B. Now, why it has been defined this way cannot be explained now, but we will look at examples and see that why it plays such an important role for us, all right, because it is not just multiplying some things, but more than that. So, as I said, we have a matrix product only when m should be equal to P. So, I can multiply. So, I have matrix m cross n, then if I want to multiply, then B has to be of the size n cross Q, and the output of this matrix is a matrix C which has m rows and Q columns. This n and n cancels out. So, you are left out with m rows and Q columns. So, let us look at examples to understand it. So, I have take A is equal to 1, 2, 3, or let me take the examples that I have taken earlier, I think, so that there will be clarity. So, 1 minus 1, 2 0 0 1, and B is equal to 3 4 5 minus 1 0 1. So, this matrix A is of size 3 cross 2, B is of size 2 cross 3. So, if I want to multiply, so A is 3 cross 2, B is 2 cross 3. So, these 2 and 2 will cancel out, the product A B will be of the size 3 cross 3. Similarly, here it turns out in this example that B is 2 cross 3 and A is 3 cross 2. So, again these 2 will cancel out, I will get the product B A which is of size 2 cross 2. So, in general, if I want to look at A times B is defined in this example. So, in the previous example, that is A is m cross n, B is n cross q, then A times B is defined and it is a matrix of size m cross q. But when I want to define B times A, then B has q columns, but A does not have q columns. So, that is not defined. So, matrix product, there are issues, but in this example everything is nice. So, let us take an example, try to understand them. So, what is the matrix product A B here? So, A B that we learn here is we have to multiply the first entry A 1 1 with B 1 1 plus A 1 2 with B 2 1, all right. So, note here this one and this one they cancel out in some sense, and I have this here the first and the first here. Similarly, 2 and 2 will cancel out here, I have got 1 here and 1 here. The next entry is going to be, it is a 3 cross 3 matrix. So, 1 2 entry. So, for 1 2 entry I need to look at A11 into B12 plus again A12 into B22. So, again observe here that 2 and 2 gives me 1 2 entry here, these 2 cancels out, this one and this 2 gives me the entry 1 2 and this one cancels out. So, here I have left out with 1 1 entry. Similarly, if I want to look at the 2 2 entry here, so I have to have 2 here and something here. Again this something has to cancel out here and I should get 2 here. So, this 2 and this 2 will give me 2 2 entry. I also have A22, again this 2 has to cancel out and this 2 should give me this 2 to get me 2 2, fine. So, this is the way I am supposed to multiply. So, I have one entry here, another entry here. So, these are the entries that I am going to get. So, in general when I write AB is a matrix C, all right, the entry of C is Cij, then Cij has to have this property that Ai has to be there, then B has to come with a j, so that these I and this j they give me Ij entry, and then the first entry, first column, first row plus again Ai2 B2j, again I and j gives me Ij here, this one and this one they cancel out. Similarly, here 2 and 2 cancels out and so on. Since the matrix of size n, so I will go till n, Ain, Bnj, this n and n cancels out, I am left out with Ij entry, all right. So, that is the way to understand that the middle part they cancel out and whatever is left out is outside. So, we generally write it as summation Aik Bkj, k is going from 1 to n, this is the summation sign that we have. Here this k and k cancels out, so you are left out with I and j. So, k goes from 1 to n, so k is 1 means 1 1 here, 2 2 here and n n here, fine. So, let us go back to our matrix that we gave here and let us compute the entry AB of 1 1. AB of 1 1 is 1 times 3 plus minus 1 times minus 1, which is 3 plus 1, which is 4, all right. So, let us proceed and compute all of the entries now. So, again let me write it, A is 1 minus 1, 2 0, 0 1, B is 3 4 5, minus 1 0 1. So, the matrix product AB is this one with 3, that is this 3 plus minus 1 times minus 1, then 1 times 4 plus minus 1 times 0, then 1 times 5 plus minus 1 times 1. Similarly, the entry is here. I would like you to check that this is nothing but 3 plus 1 is 4, 4 plus 0 is 4, 5 minus 1 or 4 plus 0, 3 plus 1, 4 plus 0, 5 minus 1. This is 2 into 3 is 6, then so 2 into 3 is 6 plus 0, then 2 into 4 8 plus 0, 2 into 5 is 10 plus 0, 0 into 3 is 0 plus minus 1, then I have 0 plus 0, and I have 0 plus 1, which is same as 4, 4, 4, 6, 8, 10, and minus 1, 0, 1. All right. Let me just clean it. I think this is too congested. So, this was 0 plus minus 1, 0 plus 0, and 0 plus 1. Fine. So, this is the matrix product AB. This we all know how to compute it, the way we have computed it. This is what we learnt in our school. Now, we would like to understand this matrix multiplication in a different way. So, what is the different way? So, let us try to see. So, I have my matrix as the first row of the matrix as 1 minus 1, or let me write it this itself. The second row is 2 0. The third row of this of A is 0 1. Now, if you look at this, this is a matrix of size 1 row 2 column, 1 row 2 column, 1 row 2 column. B is a matrix which is 2 cross 3. It means that I can talk of this times B. I can multiply these two. So, multiplying these two basically means I am looking at 1 minus 1 times this matrix B, which is 3 4 5 minus 1 0 1. This is same as, look at here, 3 plus 1, 4 plus 0, 5 plus minus 1, which is same as 4 4 4, which was nothing but the first row of AB. Just match it with this, the first row of AB. Fine. Similarly, let us look at the second row of A multiply by B, because this is 1 cross 2, B is 2 cross 3. So, this matrix multiplication makes sense. So, it is 2 0 times 3 4 5 minus 1 0 1. So, it is nothing but I am multiplying 0 to the second row here 2. So, it is 6, 8 and 10. Check that this is also equal to the second row of AB. Similarly, I can talk of, this is a 1 cross 2 matrix again, this is 2 cross 3. So, I can again multiply 0 1 times 3 4 5 minus 1 0 1, which is nothing but minus 1 0 1, which is third row of AB. So, if I look at AB, what we are saying is AB has this property which looks like this times B, this times B, this times B. So, here rows of B are being multiplied by the entries 1 and minus 1, the first rows of A. All right. And therefore, we had A of 1 I. So, I would like you to understand here one thing, that I am multiplying AB. When you multiply AB, we learnt AB multiplication using this idea, that is Aij, Aik, Bkj and summation over k. That was the idea. Our idea was looking at Aij, Aik, Bkj k equal to 1 to n. That was the idea that we had, but that is okay as far as calculation is concerned, we need to learn it. But there is another way of learning things here, which says that I can compute the first row of A B just by multiplying the first row of A with B. All right. If I want to compute the fifth row of A B, if I want to compute the fifth row of A B, I just have to look at the fifth row of A and multiply it by B. It makes sense because A is 1 cross. So, if A was m cross n, then the fifth row is nothing but 1 cross n and B is n cross q. So, this makes sense, and this gives me a matrix of size 1 cross q. So, it gives me the fifth row of A times B. Fine. So, I hope you have understood. Let us see again once I am trying to do that when I want to compute A B, I can compute A B, A times B entry wise. The A11 entry times B11 plus A12 into B21 plus so on. So, I can compute the 11 entry of AB, 12 entry of AB, 13 entry of BB and so on. Another way to compute is just compute the first row of AB, the second row of AB, the third row of AB and so on. Fine. So, this is called the row method because we are looking at the first row of AB, the second row of AB, the third row of AB. So, this was our row method of matrix multiplication. All right. Now, let us learn what is called the column method of matrix multiplication. So, we will be looking at columns to multiply things. All right. So, again the same example, I have A as 1 minus 1, 2 0 0 1, B is 3 4 5 minus 1 0 1. We already written what the rows and columns are. Again look at A is 2 cross 3. Look at the first column of B. The first column of B has size 2 cross 1. So, sorry, I wrote A wrongly, it is A is 3 cross 2. And therefore, this matrix multiplication makes sense and it gives me a matrix of size 1. So, let us multiply it out. So, I am looking at A times B of first row, so first column. So, A is 1 minus 1, 2 0 0 1. I want to multiply this with the first column. The first column is 3 minus 1. So, this is nothing but, look at it, 3 times the first column 1 2 0 plus minus 1 times minus 1 0 1, which is nothing but 3 plus 1 is 4, 6 plus 0 is 6 and 0 plus minus 1 is minus 1. So, I would like you to check that this was the same thing as in the previous example. So, let me write the previous what was AB, so that you can match it. So, AB was 4 4 4, 6 8 10, minus 1 0 1. All right. Again, let us write the other way, A times B of the second column. Again, I have 1 minus 1, 2 0 0 1. Now, the second column of B is 4 comma 0. So, it is nothing but 4 times 1 2 0 plus 0 times minus 1 0 1, which is nothing but 4 8 0. So, match it that this is nothing but, look at AB, the second column. Here it was the first column. All right. Similarly, if I look at the third column is 1 2 0 minus 1 0 1, this times 5 comma 1, which is 5 times 1 2 0 plus 1 times minus 1 0 1, which is nothing but 5 minus 1 is 4, 10 plus 0 is 10, 0 plus 1 is 1, which is nothing but the third column of AB. All right. So, we have learned this also, that I can, in place of looking at component wise multiplication of AB, we looked at computing the rows. We are also now able to compute the columns, just multiplying the matrices and the entries. All right. So, let us take an example, another example to understand it better. Why do we need such a thing? Suppose I have a matrix A. All right. So, I have some matrices A, B and C. So, the matrix A we know is 0 here, 0 here, 0 here. There is some non-zero entry here, fine. There is a 0 here. All right. So, let me make it also non-zero first. All right, 0 here. So, you can see that this is an upper triangular matrix. With A110. I take another matrix which is again upper triangular, but I have something here which is slightly different. So, this is also upper triangular, but here A22 entry is 0. All right. I want to multiply these two matrices and see what do I get, fine. So, you can multiply matrix entry wise. So, you can multiply this, the first row with the first column, you get 0 times a star times 0 and so on. You can also multiply it as 0 0 0 times a star. This star is your this one. So, say A here, B here and C here. If I write, I am multiplying by A here, that will be 0 times a star 0 plus 0 times a star a star a star. This will give me the first column, which will be nothing but 0 0 0. All right. So, here I am writing A here. All right. Similarly, so here I looked at this times the whole matrix. So, I looked at if this matrix is A, this was B, then I have looked at A times the first column of B. If I compute A times the second column of B, it will be B times 0 0 0 plus 0 times a star 0 plus 0 times a star, which will again give me 0 0 0. So, if you multiply these two matrices, what you get here is 0 0 0 0 0 0 and something here, fine. So, this is the way sometimes it helps to understand matrix multiplication. What it tells me that if I look at the matrix A, its first column was 0. So, in my B, the first row does not play a role. So, what I am saying is that if first column of A is 0, then first row of B does not play any role in AB. All right. It is only the second entries, second row, third row of B that plays the role, fine, because whatever you put, it gets multiplied by 0 and you get only 0 as such, fine. So, this is the two ways we learned what is called the row method, this is the column method. We will come to some more examples, but now we will look at another example, another multiplication. All right. What is called the, so let's see, so let me write that first. So again let me write A as whatever A was for me. A was 1 minus 1, 2 0 0 1, B was 3 4 5 minus 1 0 1, and the matrix AB was 4 4 4 6 8 10 minus 1 0 1. All right. So now I would like to look at, so again, so here I looked at till now, I was able to talk of the first row, which was 1 minus 1. This was a matrix of size 1 cross 2, B was 2 cross 3. So I could talk of this, which is again a matrix of size 1 cross 3. I also looked at A, which was 3 cross 2, and B was the column wise I looked at. So B was 2 cross 1. It gave me a matrix of size I could talk of. So A, B, this. So this was A, B, the first row. This is A, B, the first column. I can also talk of, let us try to understand this. So here I talked in terms of rows, here I termed in terms of columns. Now what about the other way around, something else? So I look at columns of A. The first column of A, if I look at, this is a matrix of size, size 3 cross 1. If I look at B, the first row of B, this is of size 1 cross 3, and therefore this matrix multiplication, so A times this into B times, first column, and this should have been the first row, this should have been the first row. All right. So I can multiply these two. If I multiply these two, what do I get? Let us see. So A, I am looking at the first column 1 2 0, and I am looking at the first row of this, which is 3 4 5. What I get is 3 4 5, 2 times this is 2 into 3 is 6 8 10, multiply by 0 get 0 0 0. All right. So I could talk of this. I can also talk of, so this was corresponding to the first column, this was corresponding to the first row of B. Now I would like to look at second column, which is again 3 cross 1, and corresponding row of B, which is 1 cross 3. So I look at A of 2 and B of this. So this matrix has entry minus 1 0 1, this has entry minus 1 0 1. So this gives me 1 0 minus 1, this is 0 0 0 0 with 1 minus 1 0 1. If I multiply, if I add these two, if I add these two, what do I get is 3 plus 1, 4 plus 0, 5 minus 1, 6 plus 0, 8 plus 0, 10 plus 0, 0 plus minus 1, 0 plus 0, 0 plus 1, which is nothing but 4 4 4, 6 8 10 minus 1 0 1, which is AB. So check that this is another way of multiplying, and you are getting to get the same answer. So what exactly we are doing here is, in this matrix multiplication is, we have written A as the first column and the second column. this is the way we wrote first column, second column. We wrote B as the first row and the second row, and we are saying is that AB is nothing but A times, so first column of A into first row of B plus second row times, second column times the second row. So, the important thing is here again note that this 2 and 2 cancels out, this 1 and 1 is cancel out. So, this is what is important, that you are able to multiply things to all. What I am trying to say is that, so let me write it. So, there are ways of multiplying matrices. One was I can compute AB ij entry directly. I can compute AB using its rows. I can compute AB using its columns. I can also compute AB using sum of matrices, sum of matrix approach. So, here approach means I am looking at A, columns of A times this, and I am looking at k is equal to 1 to n. So, these are the 4 ways in which we can do matrix multiplication. All right. And I would like you to learn this matrix multiplication. In the next class, I will take up some more examples to make you understand this matrix multiplication. Why I am trying to stress on matrix multiplication is because of the following aim of the whole course. The whole course that we are going to do is in different ways trying to prove the following ideas. So, we are trying to prove the following ideas, that given a matrix A which is m cross n, I can write A as what is called, I can use A to write A as L times U, where L is lower triangular and U is upper triangular. So, A is a matrix which is m cross n. Then I will have some issues. I cannot talk of upper triangular, lower triangular. I will have to talk in terms of forms, lower triangular matrix and upper triangular form. But if A is a square matrix, then these two make sense. We will need conditions, what are called regular conditions, all right, and they will lead to what is called Gauss elimination method. So, this is nothing but the Gauss elimination method for us. So, this is the first thing that we are going to understand is what is called writing the matrix A as LU decomposition, L for lower, U for upper triangular decomposition. Another thing we are going to learn is writing A as B times C. So, A is your m cross n, B is going to be m cross r, C is going to be r cross n, and here R is nothing but the rank of a matrix. So, we are decomposing the matrix into ranks. This is called rank decomposition or rank factorization of a matrix. Fine. The next thing that we are going to learn is writing the matrix A as Q times R. So, if A is m cross n and has rank R, so rank of A is R, then this Q will be of the size m cross R, this will be R cross n, and will turn out that, so this is called QR decomposition. The important thing is that this matrix Q transpose Q, which is an R cross R matrix, will be an identity matrix, all right. So, what we call orthogonal matrices. So, we have got 3 things, that is the basic idea that we have. This part will lead to what are called Gauss elimination method, as I said. This is rank factorization, this will also come from system of linear equation. For the keyword decomposition, we will need to learn what are called inner product spaces, so that we can understand what we are doing, orthogonalization and so on, Gram-Schmidt process. Then there are 3 more which are related with what are called eigenvalues, eigenvectors and eigenvectors, that we can write A as U T U transpose, T is upper triangular, all right, in certain, and U is unitary matrix. I have not said what is an unitary matrix till now. So, we will understand these things as we go along, but this eigenvalues and eigenvectors is going to be the last chapter. So, for that we will have to understand everything. There will be a special case of this. So, here we need that A is n cross n a square matrix. We will look at things when we can make, in place of T upper triangular, we will have T as a diagonal matrix, and then the final thing will be writing any matrix A m cross n as some U D V transpose, where U and V are unitary and D is diagonal. All right. So, in place of D, most of the books they write sigma here. To understand, this is singular value decomposition of the matrix. So, initially we will look at the first 2 examples, that is A equal to LQ, LU and the rank factorization. Afterwards, after that we will learn what are called vector spaces and then things like that. So, that is all for today, but keep track that we need to understand matrix multiplication, so that we can do all of them. Thank you.